Then, yes, we'll look at this. Very importantly, this is actually what we are dwelling on today, the spatial data, which is a fundamental component in any GIS environment. Spatial in the sense that we believe that any data that is coming into GIS environment is coded with X and Y and Z if you are dealing with 3 dimensions. So this data is based on the perception of the world as being occupied by features. So, and these features is an entity, which is always, most of time, it can actually be described with its attributes and its property. Every data has its attribute, property, location on Earth as it is mapped. So that at any time you bring it in, you can say this is where the data is falling, this is where it's not falling. So these data are actually grouped into this vector model and the raster model. So every data we are talking about must be represented in a special, the special data that are represented either they are vector or they are raster. Then when we're talking about the vector data, which is the vector model we are talking about, you say that is they are discrete data. Discrete in the sense that this is data that they can identify them by points, by lines. They are mainly points and lines. They are structured in 2 specific elements, nodes, the vertex, and the coordinates. But when you're talking about the raster data, is a representation of an area. When a data comes to represent an area or a region or the surface, when you can see a data that you find out that the surfaces are divided into grids of cells, which can form a polygon. So we'll talk about, say that this data is raster, is a raster data, and they are continuous. Then, if you look at this, now you can see some typical representation of a point entity representing a location here. Described using coordinate system of longitude, latitude, or the X and Y. At this particular location, you can see the vector data as points. So, say this is a point. From the point joining together gives you a line, which is still a vector data. But when this definitely becomes an enclosure, it becomes a polygon, which is an area that is fully encompassed by a series of connected kind of lines. If you look at here, you can see, so it becomes this. But you now find out that you can transform this data from vector data down to raster data. And when you are handling some data, you need to now understand what kind of data am I actually dealing with. Understanding their characteristics will tell you. Now look at this. Now, why do we say that the raster data is in grids? Now, if you look at these grids here, this is example of a kind of a raster data, the satellite and the dam and all that. Now, I will still go to tell you more of this. But let's look at these grids, the resolution of raster data. If you look at this, if you have a cell, this cell is 5 by 5. Is that not true? For example. Yeah? And you have another cell that is 10 by 10. Which one is which one has higher resolution? Is it the one of 10 by 10 or the one of 5 by 5?
The higher resolution. The one with 5 by 5 has a higher resolution.
Yeah. Now, why do you think the one 5 by 5 has higher resolution?
It's more zoomed in. It will give you better details, better representation of what you're seeing on ground.
Exactly. Now, because the pixels, now we'll say that they are pixelated in terms of raster data. Now this thing I'm asking you now is basic, very, you need to actually put resolution in your head whenever you are dealing with raster data. Now, most of the raster data you might be using, especially some when it comes to them, most of the time, in short, in using any data, that has to be raster and all that, it's important to try to understand what is the resolution of this data I'm even using. Do you understand? That's why you cannot collect data, for example, a data that you collected, maybe you are working an area, maybe they give you an area that is maybe 400 by 400 meter, the entire area you are working on. And you went to download the data that is captured in 500 meter by 500 meter. Do you understand? And you are using it to make interpretation without understanding the resolution of the data you are using. Do you understand?
Yes,
I've seen so many geologists make that mistake. So many of them make it use of that. You see,
it should be much smaller than the area.
Exactly. And now,
so that you can put pictures.
What is the solution? What is the solution? If where you are working is smaller and the data you have is bigger, the only thing you need to do is to do what? Is to project. You work with the data outside your area and project in right inside your smaller area. Do you understand?
Okay. Yes, I get that.
Yes, that is the only way you work. That's the only way you make use of it. You get it? Now, for example, you can see this in when we're interpreting, sometimes we're interpreting aeromagnetic data. The aeromagnetic data, the resolution most of the time is within half a kilometer. Do you understand?
Yeah.
And then most of the places we work with are in smaller regions. Now, I've seen so many people, they do their interpretation, their interpretation does not have anything to do with the smaller area they are working. That is wrong. It is because they lack the rudiment of interpreting and projecting, from outside to bring in. Do you understand? So most of the time, what they do is that they interpret one sheet. After interpreting one sheet, they will just bring the area of interest and just put it there as a dot and tell you the area of interest and look at it. They tell you they've done interpretation. That thing is not interpretation. It has nothing to do with the area where you are working. In short, open every report.
You're supposed to zoom it down.
It's not significant. That interpretation is not significant compared to the real interpretation that is required to that particular area. If somebody gives you an area of 1 kilometer by 1 kilometer or 2 kilometer by 2 kilometer, and you've interpreted the entire sheet, you should, at the end of the day, it should be narrowed down within that particular location of interest. And you must bring out the features within that same particular location, coming out from the outside to inside. Yes. You understand? So without that, most of those interpretation doesn't make sense. Though that's why you see most of the report, they will tell you interpretation. The next thing is grant truthing. Where are you grant truthing? Where are you going to?
They are all copy and paste.
Yes, just copy and paste. We are not going anywhere. We are not going anywhere. If we go into, I will tell you some of the interpretation I've done. I've got about so many experiences. There's one that I went there, not more than 30 meters away. I saw exactly what I interpreted. And I picked it on the surface. On 3-4 occasions. That has happened. It has happened in Oyo State. It has happened in Abakaliki. It has happened in Cross River. And these are places that I have no idea. I've not been there. I've not done anything and all that. In short, you find out that it is the basics of actually trying to pick one or two things you're trying to do. So, and in that aspect, everything about it is GIS. Your projections must be clean and clear. Your data sources must be very accurate. Your georeferencing must be very detailed. So many things has to. So, now you and I understand that you are not doing this because you want to go and write the exam. You want to solve problems.
Of course not. Yeah.
Of course, you are not trying to write the exam or trying to be theory. That's why I'm not talking about theory. I'm relating everything to. When I do it, I relate it back to what you need to know about it. Do you understand? So that's the difference if I'm presented and be in a GIS format. Just an estate. And someone can get that proposal and I've seen so many people doing that. And they get a very good pay for that. So that is just it. So you need to understand your resolutions when it comes to your raster data. Then now look at this. The main major raster data types are this. You understand? Because all the data you are going to be using, most of the data you are going to be dealing with, so most of the time, 80% will be raster data. Others will be maybe a kind of a vector. You understand? Vectors are easier a kind of to bring in and produce and all that. But raster data is what actually what you transform most of the time you use. You know, the satellite imagery, you know, the binary, the scan file, the graphics files, the digital elevation models, which is the DEM, or the SRTM, which is also in that format. Then digital orthophotos, you know, this is another kind of area photos that is actually corrected in such a way that when you are using them, the images, the shadows, and some of these tilting issues are actually removed from them. You know, we'll call them the orthophotos. Then let's see some of these. Like now, the raster data when it comes to satellite imagery, you know, the satellite imagery as time goes on definitely it's something you need to be, you are definitely have to be working with. The satellite imagery is actually presented in bands, you know, and this imagery can be in black and white also. There can be the panchromatics are in black and white, and the RGBs are in bands, in different bands. Like when you know, when you transform these bands into different bands, you can see different colors of satellite imagery. Now, if you look at the Aster image, you know the Aster satellite imagery makes use of 1 to 14 bands. The Landsat makes use of 1 to 7 bands. But in exploration and in mineral exploration and most of alteration mapping, I think the most important bands are 1 to 9 bands. Now, if you look at this image here and here, you can see that the colors are a bit different. If you look at here, if you look at this layer options here, this is band 321 actually combined. They give you a different color. You combine another band 432, it will give you another different color. So this is the way the satellite image also can actually be displayed, you know, because of the pixel values they contain, you know. Then that is a kind of raster. Then you look at the binary scanned image. The binary scanned image are usually in black and white, you know, they are only 1 and 2. But now when you see data and you look at you go to their property and you look at their 0 and 1, you understand that these data are actually their binary data. So you can, they are just black and white. If you see, there are some other data that when you see, you find out that the same data have different bands. And those bands, you find out you can actually transform those bands. In short, there are certain things that when you want to do, you need to make the data to be in binary format. You have to make only use of one band for that actually to be transformed or to work out. So this is another kind of raster. Then also we'll talk about the graphic files. You know, this is another kind of raster which also include the maps, the most of the photographs, and this also can also be stored as a digital graphic files. The most popular ones are these ones. I'm telling you, that the one, the portable network graphics, which is the PNG I told you of, and that of the JPEG, Joint Photographic Expert Group. Now, are you there? There's something again you need to know. Before, somebody was asking me the difference between JPG and JPEG. Huh? JPEG and JPG. You know, they are the same thing, but I think the older window doesn't take extension files of 4 like the newer windows now. Have you seen it? The newer Windows take up to 4 extension files.
4
4
characters.
characters. Do you understand? But before, I think they don't take more than 3, so it will be 3. Any extension must be 3 characters. You understand? But these days, I think they take up to 4. You know? So, but I think they are the same thing. Before, somebody was telling me they are not the same thing. I said they are the same thing. So if you see something like that, maybe older file format that is JPG, and you now see this one that is JPEG, they are the same thing. You get it?
Okay.
Then we'll look at this
The,
another one, which is
TIFF file.
then, right?
The TIFF file, TIFF.
Yes.
Is it part of that
Yeah, it is part of it. Yes, TIFF
graphics
is part
file?
of it. Yes, TIFF is part of it. That the tag
Okay.
image file format is part of it. That is actually what's stored. If you are going to be using, if you are going to be using this, if you are going to be using any application, maybe some of the geophysics application, let's say something like axis montage, I use TIFF a lot, because once you finish in montage and you want to bring them into ArcGIS, you have to just put them in TIFF. Immediately you're bringing them in, you don't need any georeferencing and all that. That's the best way to store any georeference file, so that when you are sharing it or other person is making use of it, what you just need is to bring it in. Understanding the coordinate format, it will just align where it takes. So that it does it. Then another one here is digital elevation model. Digital elevation model, you can, it's just most of the time is a point based, but it can easily be converted to raster data by placing each point on the distance on the center of each cell. So this one, the term, definitely is very important raster data that you have to know at least how to manipulate in order to possibly look at your topography. If you are trying to look at water management program, if you are working on any project that has to do with water management program, you are looking at topography, you are looking at your slope levels and all that. You need to actually understand how to manipulate your DANE. And also, you can also, all these things, you can also acquire them. There are some sites that you
Really,
can,
SRT.
yes, you can get SRTM. They are different, they are captured by different satellites.
Okay.
I think the free one now, the resolution of the free one is 30 by 30. Yeah, the one that you can get free now is 30 by 30. If we are using global mapper, I will tell you how you can capture digital elevation model of any particular location. For any site, for any location, there are some location, even in what do you call it? This I forgot this USGS. At USGS, once you register with USGS, you can actually acquire digital elevation data free of charge of any location in the world from that location. And I think their resolution is 30 by 30. Then this is the one of the area photos, the area photographs and all that. This is also a kind of a georeferenced, a kind of a georeferenced image also. When I worked with Cole, with Zuma, we use a flight to capture our mines. The entire place, we mapped it with a flight. From there to Itobe, all our mines was captured with, and when we did the LiDAR survey, and at the same time, we captured the pictures, we captured the image of the locations. And all these pictures are actually georeferenced. If you are flying a drone, with the modern technologies and everything going on now, The best thing now is to, is to fly drone to do so many mapping, especially when this insecurity is, you know, especially looking
Yes,
at
yes.
insecurity now. The best way to go now is to acquire drone. Now, some of the advantages of this raster data is that the structures most of times are very simple, and again, you can actually you can actually scan them, and they are very simple in terms of spatial analysis when you want to actually make some analysis of them. Then the same thing with data vector. Vector on, you cannot easily um, um, the data do not, we'll call it a kind of, the way you bring in data, they are not easily distorted, you know, vector data, they are not easily distorted, and they are very, very light. Most of them, when you are carrying vector data, they are very, the MBs are not as high as actually raster actually. So the disk spaces are very small. The graphics, it doesn't require high graphics for you to actually analyze them and all that. So they are very easy to actually draw and all that compared to other distance. But when you're talking about the raster, the problem with raster data, which is major problem with it, is that they are very, very big. They require space. That's why when you are downloading data, sometimes you look at the area, that's why you just go straight to the area you need. You understand? You wouldn't say because you see the data covering the entire Nigeria, you want to pick the entire Nigeria and start analyzing. Your system will close down. And the projection also, it's not easy. You can't just, it's not that easily projected. That's why when you are even looking at them, always look at the data that have the format that you are already working on. It's very interesting. It's better that you have the data in that format, than, yes. So because sometimes they are not easily, it's not all of them are easily projected. Sometimes when you project them and project, the application will be telling you not projected, can't project this data. So that is just it.